So this video explains 2D arrays in Java. In Java, 2D arrays can be used to store like a table, data with rows and columns, to process matrices or images, um, and so how do you create a two-dimensional array? Well, it's just like a one-dimensional array, except instead of one set of brackets, you do two sets of brackets. And then when you instantiate it, instead of one number, you do two numbers. The first number we think of as the row, and the second number we think of as the column. So here's a couple of examples. So, if we think of, this is just a way to remember a mnemonic, to think about row, column. Row always goes first, so I don't know if you guys have heard of RC Cola, but RC, row, and then column. So this is what a two-dimensional array, which has the been declared 310. This is what it looks like. So if we think about this first thing in the top right-hand corner, top left-hand corner, that's index 0, 0. And down at the end, that's index 2, 9 in the bottom right. And the way that it works in Java is it's really an array of arrays. So the first index 3 is how many arrays, and the second index is how many elements are in each array. So it's really three separate arrays, right? Sample 0, sample 1, and sample 2. So the way you find out how many rows is by saying array.length, and the way you find out the number of columns is array0.length. Now, it is possible for the columns, for a two-dimensional array to hold different length arrays, but we're going to always be using rectangular arrays. So when you think about data storage, right, mat in this case is a reference to the address of the whole array, right? And then if you give two indices, 0, 1, that's one element. Mat 0 or mat 1 or mat 2 are references to the entire row, the one-dimensional array, and there's no way to reference a column. So what is stored in this two-dimensional array, right? New int 3, 4. We do mat 2, 1 equals 12. Well, where does that go? Well, that goes in the third row and the second column, because remember, everything is still 0 indexed. So this is what it looks like. Everything else is 0, because remember, int arrays start out as 0. All right, and then what would this display? Chart 1, 0 and chart 0, 2. There's the answer. Okay, you can also declare an array using an initializer list. So in the same way, you have to do the declaration and the instantiation in one statement, and you put each row in curly brackets separated by commas, and then a comma between the two rows. So this is an example of how to use an initializer list. And it would create that array. So how do you traverse an array? So you traverse, if you want to traverse it in what's called row major order, which is going across the rows, you use a nested loop with the rows on the outside and the columns on the inside, and then you'd print out row, column, right? This is just another example. If we wanted to make the names all uppercase, it's just the same example though. But this is called row major order. So this is what would happen, what the output would be with this code, which is in row major order, the row on the outside. And you say row column, and first goes 5, then 9, then 4, and then once it's gone through the entire inside loop, right, the outside loop updates to 1, and then the inside loop starts at the beginning again, right, 0, 1, 2, and then 3's too big, and the loop stops. Okay. So, and that's the output that you'd get, right? Row major order 594706. So this, because this is the output. And the reason you have a break right after each line is that you have this system.out.println line after the inside loop, right? So that gives you a line feed at the end of each row. Now, if you want to do column major order, all you do, the only thing you change is you put the column loop on the outside. And notice that the column loop, right, is chart 0.length, right, while the row is chart.length. So just make sure, I would use R and C or row and column. So you keep track of, don't use I and J because it's easier than to forget which is the row index and which is the column index, right? And always put row first and then column second when you're accessing the array. So this with the column loop on the outside is column major order, and I'll show you how it works. Right? Don't change this. That's the reminder. Don't change this chart row column. If you flip this, then it'll be wrong. Okay, so let's see what happens. So now column starts out at 0, and row, right, the output goes this way, right? So it would be 5, 7. I guess we didn't walk this through, right? First, because column would start out at 0, right? And you'd go 5 and then 7. And then go to 1, 9 and then 0, and then go to 2, 4, and then 6. Okay, so those are the difference in how the output would come out. Okay, so here's just a little practice to think about how a nested loop can put values in a 2D array. So think about what this array would look like. And here's the answer. Okay, so this is a practice, right? You sum all the integers in a two-dimensional array called table, right? So it's just like summing a one-dimensional array, right? Except you've got to use a nested loop to traverse. And this would be the answer. And here's a question, how many items would be displayed, right? So think about how many times does the outside loop iterate and how many times does the inside loop iterate. Right, so this one, because it's equal to 14, it would be 14 minus 6 plus 1. This one, since it's only less than 16, would just be 16 minus 8. And you multiply them together, and that's how many times these two loops would iterate. Okay, and this is just a reminder, right, every time we deal with 2D arrays. So here's one using IK. I don't recommend IK. I recommend RC or row col. And that's it.